European engineering has given us some of the most sophisticated machinery on Earth. Precision German manufacturing, innovative French design, robust British engineering. But when it comes to tractors, brilliance doesn't always equal success. Today we're exploring 10 European tractors that were genuinely brilliant, featuring cutting-edge technology and innovative engineering that was years ahead of its time, yet they failed spectacularly in the marketplace. These weren't cheap knockoffs or poorly designed machines. These were masterpieces of engineering that farmers simply wouldn't buy. From German over-engineering to French complexity, from Italian innovation to British eccentricity, these tractors prove that being the smartest machine in the field doesn't mean you'll succeed. Let's discover 10 European tractors that were brilliant but failed miserably. Number 10. The Renault 7514 Turbo D. Starting our list with France's attempt to dominate the high-horsepower market. The Renault 7514 was a technological marvel. This beast featured a turbocharged diesel engine producing 175 horsepower, which was extraordinary for 1980. Renault equipped it with an advanced synchromesh transmission offering 12 forward and 12 reverse gears, giving operators unprecedented control. The cab was pressurized and climate-controlled, featuring ergonomic controls that were genuinely ahead of their time. On paper, the 7514 was perfect. French engineers had created a tractor that matched or exceeded anything from American manufacturers. The engine was powerful yet fuel-efficient. The transmission offered flexibility American tractors couldn't match. The cab was so comfortable that operators joked it was like driving a luxury car through the fields. So why did it fail? 3 interconnected problems destroyed it. First, complexity. The 7514 had so many features and systems that even experienced mechanics struggled with repairs. The turbocharged engine required specialized knowledge that most rural mechanics didn't have in 1980. The sophisticated transmission was a maze of gears and synchronizers that frequently needed adjustment. When something broke, and in agricultural equipment something always breaks, repairs took forever and cost a fortune. Second, parts availability was disastrous outside France. Renault's dealer network was thin in key markets like North America and even parts of Europe. Farmers would wait weeks for parts to arrive from France, watching their tractor sit idle during critical planting or harvest seasons. This was unacceptable when John Deere or Case IH dealers could get parts overnight. Third, and perhaps most fatal, was cultural resistance. North American and British farmers were deeply suspicious of French tractors. Fair or not, there was a perception that French engineering was overly complex and unreliable. Renault couldn't overcome this bias despite having a genuinely superior product. Sales were abysmal outside France, and even in France, farmers questioned whether the added complexity was worth marginal performance gains. Renault discontinued the 7514 in 1985 after selling fewer than 3,000 units globally. It was a commercial disaster that contributed to Renault eventually exiting the North American tractor market entirely. The 7514 proved that brilliant engineering, without strong distribution networks and cultural acceptance, equals failure. Number 9. The Fiat 1300 DT Super. Italy's Fiat brought genuine innovation to agriculture with the 1300 DT Super, a tractor featuring an advanced differential lock system, synchronized transmission, and revolutionary hydraulics. What made it truly special was the fully synchronized gearbox, rare in tractors at the time, allowing smooth shifting while moving. Fiat's engineers created a machine that was genuinely pleasant to operate, with car-like controls and refinement that American tractors completely lacked. The 1300 DT Super was also beautifully designed. Italian industrial design wasn't just for sports cars. The tractor had clean lines, an elegant profile, and attention to aesthetic details that made it arguably the best-looking tractor of its era. Everything about it screamed sophistication and modernity. But sophistication was exactly the problem. The synchronized transmission, while smooth and pleasant, was fragile in heavy agricultural work. Farmers discovered that the synchros would wear out quickly under the constant loading and unloading typical of field work. Replacement was expensive and required skilled technicians. The differential lock system was mechanically complex and prone to failure when exposed to mud, dust, and moisture. The hydraulic system was another issue. Fiat's advanced hydraulics offered precise control, but required specific oil specifications and regular maintenance. Farmers accustomed to American tractors that tolerated neglect found the Fiat demanding and temperamental. Skip an oil change and the hydraulics would fail. Use the wrong fluid and seals would deteriorate. It required care that many farmers simply weren't willing to provide. Power was also questionable. The 1300 DT Super's 65 horsepower was adequate for Italian farming conditions, but underwhelming for North American operations. Farmers wanted brute strength, not sophisticated refinement. When a $12,000 Italian tractor couldn't outwork a $9,000 American tractor, the decision was easy. Fiat sold maybe 5,000 units internationally before focusing on their home market. The 1300 DT Super taught the industry that refinement and sophistication don't sell tractors. Farmers wanted tough, simple, powerful machines that any mechanic could fix. Italian elegance couldn't compete with American pragmatism. Number 8. The Deutz D80 06 Air-Cooled 1974. German engineering at its finest and most problematic. Deutz's D80 06 featured an air-cooled diesel engine that eliminated the need for liquid cooling systems. No radiator, no water pump, no coolant, no freezing, no overheating from coolant loss. In theory, it was brilliant. Air-cooled engines are simpler, lighter, and eliminate entire failure modes. Deutz marketed it as the ultimate in reliability and simplicity. The air-cooled engine was genuinely innovative. Deutz used forced air cooling with a large fan and precisely designed fins on the cylinders. The engine maintained proper temperatures across a wide range of conditions. In testing, the system worked flawlessly. Deutz was convinced they'd revolutionize tractor engines. Then farmers actually used them, and the problems emerged immediately. The air-cooled engine was incredibly loud, far louder than liquid-cooled engines. The massive cooling fan and lack of water jacket insulation meant the D80 06 sounded like an aircraft engine. Operators hated it, suffering hearing damage and fatigue from constant noise. The noise was so bad that some countries considered banning the tractors as public nuisances. Dust was another killer. The cooling system sucked enormous volumes of air across the engine, which meant sucking enormous volumes of dust, chaff, and debris. The cooling fins would clog constantly, requiring frequent cleaning to prevent overheating. In dusty harvest conditions, operators had to clean cooling fins multiple times daily. This was exactly the kind of maintenance farmers hated. The engine also struggled with consistent power delivery. Air-cooled engines are more sensitive to ambient temperature than liquid-cooled designs. On hot days, the D80 06 would lose power as the engine struggled to maintain proper temperatures. On cold days, it took forever to warm up. Farmers wanted consistent performance regardless of weather, and the D80 06 couldn't deliver. Deutz sold the D80 06 for only 4 years before discontinuing it in 1970. While Deutz continued using air-cooled engines in some smaller tractors, they abandoned the concept for large agricultural tractors. The D80 06 proved that eliminating one problem, liquid cooling, can create worse problems, noise and dust sensitivity. Number 7. The Lamborghini R6 130 DCL Grand Prix, 1982. Yes, that Lamborghini. Before they focused exclusively on supercars, Lamborghini made tractors, and the R6 130 DCL Grand Prix was their flagship. This machine featured a 6-cylinder turbocharged engine producing 130 horsepower, sophisticated four-wheel drive system, and a cab that wouldn't look out of place in a luxury sedan. Lamborghini brought supercar engineering philosophy to tractors, and the Grand Prix was breathtaking. The engine was a masterpiece, smooth, powerful, and refined. The four-wheel drive system used advanced differentials and transfer cases that distributed power intelligently based on traction needs. The transmission offered 15 forward speeds with seamless shifting. The cab featured leather seats, premium sound insulation, and controls laid out with Italian design sensibility. This wasn't just a tractor, it was a statement. But statement pieces don't always make practical tools. The Grand Prix was hideously expensive, costing nearly double what comparable horsepower American tractors cost. Farmers couldn't justify the premium for leather seats and Italian styling. They wanted return on investment, not automotive-inspired design philosophy. Complexity was crippling. Every system on the Grand Prix was sophisticated and high performance, which meant every system required specialized maintenance. The turbocharger needed premium oils and regular service. The four-wheel drive system was mechanically complex and prone to expensive failures. The transmission, while smooth, required precise adjustment and costly parts when problems arose. The final killer was Lamborghini's tiny dealer network. Outside Italy, finding a Lamborghini tractor dealer was nearly impossible. Parts took months to arrive. Mechanics had no training on the systems. When a Grand Prix broke down, which sophisticated machines inevitably do, it could sit for months waiting for parts and expertise. Lamborghini sold maybe 200 Grand Prix tractors before discontinuing the model in 1984. The losses were substantial enough that Lamborghini began withdrawing from the agricultural market entirely, eventually selling their tractor division to Same. The Grand Prix proved that automotive luxury doesn't translate to agricultural success. Farmers wanted workhorse reliability, not supercar sophistication. Number 6. The Ford UK County 164 Forward Control, 1971. Britain's contribution to tractor innovation. The County 1064 featured a radical forward control design where the operator sat ahead of the engine, similar to a bus or delivery van. This configuration provided unprecedented visibility and maneuverability. County engineering was brilliant, creating a tractor that could navigate tight spaces and give operators perfect sight lines to implements and terrain. The forward control layout offered genuine advantages. Operators could see all four corners of the tractor, making precision work easier. The short wheelbase and excellent weight distribution made the 1164 surprisingly maneuverable despite its size. For work requiring careful positioning, orchards, vineyards, confined spaces, the 1164 was genuinely superior to conventional tractors. But the design created problems that outweighed the benefits. First, safety. Placing the operator ahead of the engine meant in a frontal collision or rollover, the operator was the first point of impact. Several serious accidents involving county forward control tractors created liability concerns and damaged the model's reputation. Safety regulators began questioning whether the design should even be legal. Comfort was another disaster. The cab was cramped and awkward, with the operator's legs straddling a narrow platform above the front axle. Long days operating a 164 were physically exhausting. The engine was directly behind the operator, making the cab hot and noisy despite insulation attempts. Operators complained of fatigue and discomfort that conventional tractors didn't cause. Maintenance access was terrible. The forward control layout meant the engine was buried under the operator platform and cab. Simple tasks like checking oil or changing filters required removing panels and squeezing into tight spaces. Major repairs required partially disassembling the cab structure. Mechanics hated working on them, and farmers hated the downtime involved. County produced forward control tractors until 1983, but sales were always disappointing. Most buyers were niche operations that absolutely needed the visibility and maneuverability. General farming operations overwhelmingly chose conventional designs. The County 164 proved that solving one problem, visibility, can create bigger problems in safety, comfort, and serviceability. Number 5. The Valmet 502 Hydraulic Drive, 1978. Finland's Valmet introduced something genuinely revolutionary with the 1502, a tractor using hydraulic drive instead of mechanical transmission. The engine powered hydraulic pumps that drove hydraulic motors at the wheels. This eliminated the transmission, clutch, and most mechanical drivetrain components. Speed and power were infinitely variable through hydraulic flow control. It was elegant, sophisticated, and genuinely innovative. The hydraulic drive system offered real advantages. Infinitely variable speed without shifting meant operators could match travel speed perfectly to conditions. The lack of mechanical transmission meant smoother power delivery and theoretically better fuel efficiency. Maintenance on transmission components disappeared entirely. On paper, hydraulic drive was the future. Valmet's engineering was impeccable. The hydraulic system was precisely calculated and beautifully executed. In controlled testing, the 1502 performed flawlessly. Valmet was convinced they'd created the next generation of tractor drivetrains. Then reality intervened. Hydraulic systems generate enormous heat, and the 1502's hydraulics generated more heat than Valmet anticipated. The cooling system struggled, especially during heavy draft work in hot conditions. Hydraulic oil would overheat, reducing efficiency and potentially damaging components. Operators had to monitor oil temperatures constantly and reduce work intensity when temperatures climbed, which was unacceptable during time-sensitive operations. Hydraulic drive was also terrifyingly expensive to repair. When hydraulic pumps or motors failed, replacement costs were astronomical compared to transmission repairs. The specialized components required factory parts and expert technicians. Rural mechanics couldn't fix them. Farmers faced catastrophic repair bills and extended downtime. Power efficiency was questionable. While Valmet claimed better efficiency, real-world testing showed the hydraulic drive consumed more fuel under load than conventional mechanical drivetrains. The conversion losses from mechanical to hydraulic and back to mechanical meant the 1502 was actually less efficient than simpler designs. Valmet discontinued the hydraulic drive 1502 in 1982 after minimal sales. They returned to conventional transmissions and never attempted hydraulic drive again. The 1502 taught the industry that elegant engineering solutions must still be practical, economical, and reliable. Hydraulic drive was elegant but failed on practicality and economics. Number 4. The Steyr 850 CVT prototype, 1995. Austria's Steyr developed one of the first continuously variable transmission systems for agricultural tractors. The 815 CVT used a sophisticated belt and pulley system that provided truly infinite speed variation without any steps or shifts. It was remarkably smooth, efficient, and represented the future of tractor transmissions. Steyr invested heavily, believing CVT would revolutionize the industry. The CVT system was genuinely impressive. Operators could set a desired speed, and the transmission would maintain it perfectly regardless of load variations. This was ideal for operations requiring consistent travel speed like planting or spraying. The smoothness eliminated the lurching associated with gear changes. In demonstrations, the 8550 CVT was magical to operate, but Steyr was too early. CVT technology in 1995 wasn't robust enough for heavy agricultural work. The belt system wore rapidly under the constant loading and unloading typical of field work. Replacement was expensive and required specialized skills. Farmers discovered that belts might last only 500 to 800 hours before needing replacement, compared to transmissions lasting 5,000 hours or more. The CVT system was also sensitive to contamination. Dust and debris infiltration would cause premature wear and slipping. In dusty harvest conditions, the CVT required frequent inspection and cleaning. This maintenance burden was unacceptable to farmers who expected transmissions to be essentially bulletproof. Power handling was limited. The CVT system in the 850 could reliably handle about 120 horsepower. Farmers wanting more power had to choose conventional transmissions. This limited the CVT's market to mid-size operations, reducing potential sales. Cost killed the 850 CVT. The transmission added enormous expense to an already premium-priced tractor. Farmers couldn't justify paying 30 to 40% more for smooth shifting when conventional transmissions worked fine and lasted longer. Steyr built fewer than 100 CVT prototypes before abandoning the project in 1997. Interestingly, Steyr was right about CVT being the future. Modern CVT systems in today's tractors work beautifully, but they required 2 more decades of material science and engineering refinement. The 8150 CVT was brilliant but premature, proving that being first to market with immature technology is worse than being second with proven technology. Number 3. The Fendt Xylon, 1997. Germany's Fendt created the Xylon as a revolutionary compact tractor featuring a mid-mounted engine, 4-wheel steering, and modular implement attachment system. The mid-engine layout provided perfect weight distribution and allowed front and rear implement mounting simultaneously. 4-wheel steering gave the Xylon an incredibly tight turning radius. It was genuinely innovative and brilliantly engineered. The Xylon's capabilities were impressive. The mid-engine design meant excellent traction on both axles without additional weight. Four-wheel steering allowed crab steering for working alongside rows and pivot steering for maneuvering in tight spaces. The modular implement system allowed quick attachment of various tools. For specialized operations like vineyard work or municipal maintenance, the Xylon was potentially ideal, but Fendt made critical mistakes. First, the mid-engine layout created a massively complex machine. The engine placement meant awkward serviceability, with many components requiring special tools and procedures to access. Routine maintenance that took minutes on conventional tractors took hours on the Xylon. Mechanics hated them. The four-wheel steering system was mechanically complex and prone to failure. The steering mechanism required precise alignment and regular adjustment. In dusty, dirty agricultural environments, the steering components wore rapidly. Repairs were expensive because Fendt had used proprietary components throughout. There were no aftermarket alternatives. The modular implement system, while innovative, was also proprietary. Farmers couldn't use standard three-point implements without adapters. This locked them into Fendt's implement ecosystem, which was limited and expensive. Farmers resented being forced into proprietary systems when open standards existed. Price was absurd. The Xylon cost as much as conventional tractors with 50% more horsepower. Farmers couldn't justify paying premium prices for a specialized tractor with limited applications and questionable reliability. Fendt discontinued the Xylon in 2001 after selling only about 1,500 units globally. It was a commercial disaster that cost Fendt tens of millions in development. The Xylon taught the industry that innovation must serve clear market needs, not just demonstrate engineering capability. The Xylon was a brilliant solution, looking for a problem that most farmers didn't have. Number 2. The same Laser 150 Electronic, 1988. At number 2, we have Italy's same Laser 150, one of the first fully electronic tractors. This machine featured electronic engine management, electronic transmission control, electronic hydraulics, and an onboard computer that monitored and controlled everything. For 1988, this was science fiction level technology. Same marketed it as the intelligent tractor that would optimize performance automatically. The electronic systems were genuinely advanced. The computer adjusted fuel delivery for optimal efficiency, managed transmission shifting for best performance, and controlled hydraulic flow for precise implement operation. Operators could program different profiles for different operations. The dashboard featured a digital display showing real-time performance data. It looked like something from the 21st century. When everything worked, the Laser 150 was impressive. The electronic controls delivered smooth performance and genuine efficiency gains. The computer optimization actually worked, providing better fuel economy than manual operation. Same's engineers had created something genuinely ahead of its time, but 1988 electronics couldn't survive agricultural environments. Dust infiltration caused sensor failures. Vibration loosened connections. Temperature extremes from morning frost to afternoon heat caused component failures. Moisture from dew or rain infiltrated electronic modules, causing shorts and failures. The Laser 150's sophisticated electronics failed constantly in real-world conditions. Repair was a nightmare. In 1988, rural mechanics had no training in electronic diagnostics. Same dealers struggled to support the system. Specialized diagnostic equipment was required to troubleshoot problems, and most dealers didn't have it. Farmers would wait weeks for same technicians to arrive from Italy, watching their high-tech tractor sit idle during critical seasons. The electronic systems also created dependencies. When the computer failed, the tractor was completely inoperable. Conventional tractors might limp along with failed components, but the Laser 150's integrated systems meant one failure could disable everything. This single point of failure design was unacceptable to farmers who needed reliability above all else. Same discontinued the Laser 150 in 1991 after selling fewer than 300 units. The financial losses were substantial. Same learned that electronic controls needed another decade of development before being ready for agricultural environments. Today, electronic controls are standard, but Same was too early with technology that wasn't mature enough. The Laser 150 was a brilliant vision executed with premature technology. Number 1. The Schlüter Trac 2500 VL, 1979. And here's the most spectacular failure in European tractor history. Germany's Schlüter Trac 2500 VL was the most advanced, most powerful, most sophisticated tractor ever conceived when introduced in 19. This monster featured a 250 horsepower V8 diesel engine, full-time articulated four-wheel drive hydraulic implement coupling system, computerized monitoring, and a cab that looked like a spaceship interior. Schlüter believed they'd created the ultimate tractor that would dominate the industry. The Trac 2500 VL was genuinely extraordinary. The articulated four-wheel drive system provided incredible traction and maneuverability. The V8 engine delivered massive power smoothly. The hydraulic implement system allowed tool-free implement attachment in minutes. The computerized monitoring tracked performance and alerted operators to problems before they became failures. Every aspect was cutting edge. In demonstrations, the Trac was breathtaking. It would pull loads that conventional tractors couldn't move, maneuver in spaces they couldn't navigate, and do it all with operator comfort and sophistication that seemed decades advanced. Agricultural journalists declared it a masterpiece. Schlüter received international orders and expected to dominate the premium tractor market. Then customers actually bought them, and disaster struck immediately. The Trac was so sophisticated that it was essentially unrepairable outside Schlüter's factory. The articulated drivetrain used proprietary components available only from Schlüter. The V8 engine required specialized service that few mechanics could provide. The computerized systems needed diagnostic equipment that didn't exist outside Germany. Every failure meant shipping the tractor back to Schlüter or waiting months for factory technicians. Reliability was abysmal. The articulated frame joints wore rapidly and required constant adjustment. The hydraulic implement system leaked constantly, spraying expensive hydraulic fluid everywhere. The computer systems failed in dusty agricultural environments. Operators reported spending more time maintaining the Trac than actually working with it. The final disaster was price. The Trac 2500 VL cost more than twice what conventional high-horsepower tractors cost. When farmers calculated cost per hour of actual work, considering the constant maintenance and downtime, the Trac was catastrophically uneconomical. Most buyers demanded refunds or traded them at massive losses. Schlüter sold fewer than 150 Trac 2500 VL units before discontinuing it in 1982. The financial damage was devastating. Schlüter never recovered, eventually being absorbed by other manufacturers. The Trac 2500 VL became legendary as the most over-engineered, most expensive, most spectacular failure in tractor history. The Trac taught the industry's harshest lesson: sophistication without reliability equals failure. Farmers don't want the most advanced tractor, they want the most reliable tractor. Being too sophisticated for your support infrastructure is worse than being too simple. The Trac 2500 VL was brilliant, revolutionary, and completely impractical. It was German over-engineering taken to its ultimate catastrophic conclusion. Which failure surprised you most? Do you have experience with any of these European tractors? Share your stories in the comments. I'd love to hear real-world perspectives on these machines. And if you enjoyed this exploration of brilliant failures, smash that like button and subscribe for more deep dives into agricultural history, vintage equipment, and the lessons learned from both successes and spectacular disasters. Hit that notification bell so you never miss our next video. Thanks for watching, and remember, the graveyard of innovation is filled with brilliant ideas that were too advanced, too complex, or simply arrived at the wrong time. These European tractors were brilliant, but brilliance without practicality equals expensive failure. I'll see you in the next one.